Hey, what's up? I just want to take a quick second to talk about how I'm importing the KKit character animations into my Vision Pro project. Um, this particular this particular asset pack is just a bunch of animations for the standard KKit characters. He's got two different sizes. He's got medium and large characters. This asset pack contains animations for both. There's more animations for the medium characters, but there's a good number for the large characters as well. But let's go over how we actually import these into Reality Composer Pro so we can use them in our visionOS projects. To start off with, though, we have to take a detour into Blender, where the majority of the work is done. So this particular script will utilize the Blender exporter to iterate over the actions that are contained within Blender and create individual USDC files for those animations. Um, we'll see that in a second. Just to kind of quickly go over the script from top to bottom, there should be a link to the gist if YouTube allows it that has the code. This is a simplified version. You can go through and make it so that this script will be an operator that's available in the export menu that you can use to use the file open and save dialog, so you can choose and be fancy. I am not being fancy for this demo. I am hard coding the path where I want this to export out. Uh, and we are going to be working with the medium character and the basic animations for the medium character for this video. So the first thing that we do in this particular script is that it works on the selected object. And if there isn't a selected object, it just starts out and fails. We will capture the frames per second and the current length of the timeline so that we can restore those at the end. We will check to see if there's any animation data. If not, we just create it. Skipping over, again, some minor details. We then iterate over all of the actions in the scene, getting the start and end times to calculate the length. If the animation is too small, we ignore it. That's currently set at 5 frames. That's just for historical reasons for some of the asset packs that I was using. At that point, we will go through, and again, there will be a link to the code, and I have a commented version that'll comment everything out. I'm sorry, not comment everything, but have comments to as what everything is doing. But essentially, for each action, we will go through and we will fix the name if we need to. We will take the path that we have set up when we called into this method and create an export path that is the action name with a USDC extension. We will then take the action and we will append that action to a new empty strip, and we will mark that track that contains the strip as the one we want to export, or the one that we want to influence the timeline, which is the one that will be exported. Then we will call the Blender USD export function, configured to only export out the things that we want. In this case, it's going to be export animation equals true. If this is false, it will only export out the current frame that's selected in the timeline. So if you want the entire animation, you have to set export underscore animation equals to true. The only other thing that we export out are the meshes. And this is because if we don't have the meshes exported, Reality Composer Pro will not associate the animation with our character, and it essentially fail invisibly unless those meshes are available. I'm sure there's probably another way to get this to work, but this is what's working for me right now. Any suggestions would be appreciated. But again, so we iterate over each of those actions. Those actions will be exported out to the as a named USD file, and then we can import those into Reality Composer Pro. So to see this in action, let's go to our Finder where we have the animation pack downloaded. Again, there's folders rig large and rig medium. We're going to be dealing with the medium one for this video, and we're going to want the basic movement script. So we're working with the GLTF version. So we have a GLB, which is the binary version of GLTF. So we're going to take this, drag this into Blender. We're going to accept the default import options. and that gives us our mannequin character. And if we look at our NLA action uh, uh, editor here, not the editor here, but the viewer here, or outliner, or whatever you want to call it, we'll have a number of animations that will be exported out once we run this file. The only thing we do is that we want to make sure our entire mesh is selected. So I always do select hierarchy, and then I hit the play button. And that's it. That has now exported out all of these animations as USDC files. And if we look in the Finder, we now have, if we go to our basic, these are now the animations that have been exported from that GLB file. If you take these animations and drag them into Reality Composer Pro, you can now associate those with characters that you have already exported out. So let's take a look at Reality Composer Pro, where I have already exported out all the medium and large animations into Reality Composer Pro. They've already been imported, and we have those available to us. We're going to be working with two characters, and you kind of see a preview of what we're going to run into. We're going to be working with a paladin character, and then we're going to be working with the skeletal warrior, which I have already imported and configured into Reality Composer Pro. And all you do to add these animations in once they're in Reality Composer Pro is with your animation library, and you can add this if it doesn't already exist. You just add in an animation component. But once you have your animation component, you hit the plus sign here, and you go to your folder that you want to add in animations. In this case, we already did some example ones. Let's do ranged. Let's do a ranged magic summon. Select this one, and if we click on ranged magic summon, hit play button, now our character is animating. And you can see our problem is that the helmet doesn't actually move with the character. And that's because it's not actually attached to the rig. It's kind of just like a child of the skeletal warrior. So we actually need to fix that. But we cannot fix it here in Reality Composer Pro. We have to fix that in Xcode. And just as another example, if you just looked at idle, which I did at first, I just looked at idle like, oh, idle looks great. Um, and then I tried to do like cheering or running and found out that the helmet's not moving. So we have to figure out how to actually fix that. But the good news is it's actually fairly easy to fix in Xcode. It's just um, a little bit extra work, which is unfortunate. But if we go into, not Safari, if we go into Xcode, what we can do is for our skeleton character, we are going to look for, in this case, it's rig medium, but it's whatever entity actually has the armature that's attached to it. So in our case, we're looking at rig medium, which is standard for the KKit characters. We look for rig medium, and there are a number of joints within rig medium that you can access. They have this joint path that's pretty long, but you can essentially what you're looking for are root nodes. So something like spine wouldn't be a good one to attach to. You could, I believe you can. There's nothing that's stopping you from attaching to spine. But in this case, we're looking for like the hand slot, or we're looking for the head, something that we can attach our entity to. So in our case, since we're dealing with a helmet, we want the head. And the good news is that you can actually attach either with the leaf node name or the full path. So in this case, we're just going to use the leaf node name. So we're going to set up a number of pins on the rig associated with these joint names. So we've got skeletal joint name head, and we're going to create a pin called head. We've got skeletal joint name hand L, which is your left hand, hand R, which is right hand, and then your hand slot L, hand slot R, left and right hand slots, respectively. And then we have the chest. We're going to set up all of these pins, and typically with the rig medium characters, because you want them to be interchangeable as much as possible, is you'll set up the same set of pins no matter which character you're dealing with. In this case, we only need the head. So in this case, all we do is we find our helmet, which is the entity that's not animating correctly. In this case, it's called Skeleton Warrior Helmet, and we pin it to the head. Now, I'm using a custom pin entity component here, All we're doing is we're telling it which component it's pinned to. We're telling it the name of the joint that it's going to be pinned to. And then we're saying, because we're coming from Blender where the Z is up, we actually need to do a rotation to correct the orientation when we're actually running through this. We're actually moving this object to track the pin. The pinned entity component is fairly simple. Again, all it's doing is each update frame, it's taking a look at the pin, and if first of all, if we don't have the component, we continue. If our pinned entity is nil, so it's been deleted or removed from the scene, we remove the object itself just so that we don't have orphaned pinned entities in our scene. All we do at this from this point on is we just set our position orientation to match the pin. This is an example of where it would have been nice if I were looking at Apple sample code because they have a joint pin component. That's pretty much this exact code. It's a little bit nicer. It supports an offset, which we'll kind of see. If you don't have an offset, sometimes the joint isn't exactly where you want it to be. So it's nice to be able to have an offset to position the pinned entity. So I will likely move to that. I didn't actually need it for this example. I'll probably move to that in the future. I believe that sample code's in the botanist. The botanist sample code this is called joint pin component. So take a look at that if you want like the official Apple version of this. But this is my version and it worked for me and it's continued to work for me. All right. So anyway, back to our rig. So sorry, back to our code here. So in this case here, all we're doing is we're loading in again for our skeleton character. We're looking for the medium, the rig medium. We're setting up a number of pins that we'd like to track, and then we're pinning the helmet to the head pin that we set up earlier. And if we hit the play button, we should see. I'm running this on the Mac, but this works the same exact if you're running it on visionOS. Which is the nice thing about Reality Kit is actually it is fairly easy to have a Mac version and a a visionOS version, as long as you have the OS cars in place. So in our case here, if we have our paladin character, we have our skeleton character. Excuse me. If we click on them, they will go through their animations that we have configured on them, and you can see that the helmet is actually tracking appropriately. You can also see that the skeleton is holding a book. So since we did have those other pins, we just put a book in the skeleton's hand. Again, but we could do an offset, scrubbing an offset. We could specify a transformation that would fix this book so that it's held in a different orientation if we wanted to. The same thing with the paladin's hammer and the paladin's shield. Those are both attached with that pinned entity component. And if we wanted to, again, we could specify a transformation that would, maybe if we wanted the hammer to face a different direction, we could do that. So in this case, it might make sense to rotate that hammer so that he's actually striking with the narrow edge versus the wide edge. But for this example, we don't really need that. But yeah, if we kind of go back to the code here, it is, fairly simple. Like once you know what you have to do about setting up the pins, actually it's fairly easy to set up and pin those entities to the skeletal joints. And then the Blender code in and of itself, if I can find Blender, yeah, the Blender code. Again, if YouTube lets me, I'll put a link to the gist, but it is fairly simple code here. I'll just leave this here so you can see it. But again, all we do is iterate over the actions that are in the scene. And for each of those actions, we export out a USDC file per action using the built-in USD export method. So that's the very, very nice thing about Blender is that it is extremely customizable and there's a lot of support for scripting. So this actually made it super simple once you kind of figure out what you have to do, what methods you need to call to export out something.